Next, if people are okay with me continuing, I want to show how to upgrade, so some of the admin type tasks that we can do. So, okay, what we're going to do is we've just arbitrarily decided that there's been a bug introduced in the latest version of Cockroach, and we need to downgrade from 1.1.4 to 1.1.2. How do we do this? In kubectl, there is an option to edit a stateful set of the stateful set defined in the YAML file, which is in this case CockroachDB. Open that up. It should launch your default text editor, in my case Notepad, and this is very similar to the YAML file that we were looking at before, the stateful set elements. So if we find where it's got image, we can specify and change what image it will use when it creates a new pod. Downgrade it to 1.1.2. Now also, just a note here, we can check what the update strategy of the pods are. So when it detects that there is a difference between the image version, image information, and the actual image that is running on the pod as the default, what type of update strategy do you want to use? Now this is set to rolling update. It can be set to none, which means that we would have to manually run through this cycle. Rolling update is a nice one. Now if I save that and I'll close that, it will mark it as now edited, and it will apply that one. Now if I do a get pods, what we can see straight away is one of the pods is now terminating. Now being terminated, and its container should be creating. While that's running, if we go back over here and do view nodes list, we can see that pod 2 waiting for it to actually do its thing. Oh, should be now on it. For me now. Yes, here you go. Cockroach 2 has been restarted a few seconds ago, and it is now version 1.2. So it will go through a round robin. It will connect to, it will shut down one of the pods, apply the correct CockroachDB version, and then restart that pod. Once that's been fully restarted and marked and is up and running, it will then move to the next one, and going backwards in order. So it will go from the highest number back. So hence it applied it to 2, then to 1, then back to 0. Now what you'll see is because one of the nodes that will have recreated will be the CockroachDB 0, which is what I've got the port forwarding set to go to. So it has, I've lost the connection to the CockroachDB node. So if we run that one, we can see it's still restarting pod 0. It's created it. Now it's up and running. Now, I have had challenges when recreating the, restarting the pod, which is currently set to port forward to. I need to re-expose the port of that pod. So to re-expose that port, I go through this process. So we would need to first of all delete the service that we created, then recreate it, and then view the new port mapping. There is probably a way where you can specify which port to expose externally, but I haven't yet figured out how to do that. So if I run those ones, we can see it's now being exposed as 32628. If I change that to we can see very nicely Cockroach is telling me that I'm using older versions of the nodes, and if we go into the view nodes, they're now running at 1.1.2. So the individual nodes will be restarted when a cluster, when they talk about in NoSQL and this kind of cluster technology, they say being able to do upgrades with no downtime. What they mean is that the cluster will stay up. Applications need to be able to handle that their connections to the cluster will get killed and that they will need to be reconnect. And so applications have to be able to handle those errors. Even if it's in the middle of running something, your command got killed, you go back, you need to retry your command. It'll be run as a transaction, so you won't have changed the state of the command, so it will be safe to rerun. But applications need to be aware of that in terms of the thermal nature of the connections. Okay. So after we expose that, okay. Next thing I was going to show you, as well as upgrading, we turn around and say, you know what, this cluster isn't big enough. We want to test what it's going to be like to have more than 3 nodes in the cluster. Kubernetes gives us a really, really nice way to do this. We can basically fail our stateful set, which DB, and we want to change the number of replicas to a higher number. In this case, I'm going to go 5. Now, if I get the pods, it's already created the 4th one, and it's about to create the 5th one. There we go, we now have 5 pods running. And if I refresh my page, there we go, I've got 5 pods running, handling the Cockroach cluster. Unfortunately, to scale back down isn't anywhere near as nice to use. Because if you change the replicas back down to 3, Kubernetes will stop the individual pods, and Cockroach will think that they've died and won't have rebalanced the replicas around the network correctly. So it's more painful to scale back down. So instead, what we would need to do is we need to decommission each of the nodes that we're going to try and get rid of. And once they're decommissioned, then we can tell Kubernetes that there is fewer of them to actually go around, so that they can be dropped off the network. So to do that, I am going to use a very nice thing, which is if you're using Visual Studio Code and you've got the Kubernetes plugin, which I highly recommend, it'll show you information about your Kubernetes cluster, and we can go to any of the pods. In this case, I'm going to go to randomly to pod 1, and we can open up an SSH terminal straight to it, which is nice. So now on here, so internally, it's basically just got Cockroach itself. So I can run a Cockroach command, and I could have run the SQL client directly from here. But in this case, what I wanted to do is I want to list out the nodes. Oh, sorry. Every command that you run against a Cockroach, because we started it as insecure, has to have the -- insecure. Okay, so this is giving me the information about what all the nodes are actually running, and so I could have used this to check the status in the build versions as well. They were shown before through the web page. So we can see 4 and 5 node IDs were the ones that were created latest, and they're the ones which we're going to get rid of. So we would instead do push node decommission with 2 S's, not 3, and we give it the node list, and they're currently running. So we would specify wait equals all. If we're getting rid of them because those nodes have actually physically died or something's gone wrong and they've been shut down, we would use it to wait equals live, which basically says don't hang around waiting for a response from the node, from the Cockroach node. And all these commands have to have a secure editor. Now that'll sit there waiting for them to shut down. So, what we can see here is the number of replicas have got dropped down to 0. So if we go down to replication, we can see that those nodes, leaseholders, here we go. The number of replicas was balanced at around about 10 or 11 across all the clusters. Then you can see down here, 2 of the nodes have been allocated and they've gone down to 0 in terms of the number of replicas. The toolcom seems to be showing the incorrect information, but you can see that from the lines. Now, that's basically marked those 2 nodes as now decommissioned. We can then look at, again, this is a bit annoying because of how wide it is, so I'll read on that slightly better. We can see 4 and 5. So what we're looking for is gossip replicas is decommissioning and is training. So what we can see here, first 3 have 17 replicas on each node, and the last 2 have 0, which is exactly what we want, so that they've now been ready to be decommissioned. Now we can exit off that terminal. At this point is when we change the replicas back down to 3. Pods, we can see that now it's terminating each of those nodes. And if we refresh this page, you can see that terminating, and eventually so we can see the 4th node has now disappeared off, and it's now terminating the 3rd node. So we should be able to drop it. Well, eventually, as a decommissioned node, I won't wait for it in terms of what it's actually doing. But that's how you safely decommission it down. Revisit it as we go forward with the next one. By the way, now I can look at my, it's been plenty of time now, we can see that my cluster is actually 3 nodes, which are, but I've got 2 nodes that have been decommissioned. from the previous run. So, which is quite nice to see.